Hello, students. Welcome. Today, we're going to look at a very interesting and, a very practical topic, some applications of D and F block elements. Now, you might think these are just names in your textbook, right? But you'll see, they are actually all around us, powering the technology we use every single day.
So let's start with a question. Have you ever wondered what is actually inside your smartphone that makes it so powerful? You know that bright glowing screen, the really loud speaker, that battery that lasts all day? It's all just chemistry at work. Well, the secret, it lies with some very special elements from our periodic table, the D and F block elements. You see, these are the hidden materials that make almost all our modern technology work. And by looking at their applications, we'll get a much better feel for their unique chemical properties. All right, Section 1, Chemistry's Specialists Toolkit. Now, to understand why these elements are so crucial, I want you to think of them not just as names on a chart, but as a specialist's toolkit. Imagine chemistry is a big workshop. Well, these elements, they are the high-tech precision instruments you find inside. So let's explore this idea a little bit more. If you think about the main group elements, like carbon or oxygen, they are like the general-purpose tools in our workshop. The hammers, the saws. They're great for building the basic structure. But the D and F block elements, they are the specialized power tools. They're the ones you need for very specific, very demanding jobs that the basic tools just cannot handle. Okay, so what is the secret behind their special abilities? Why are they the specialist tools? Well, it all comes down to their electron structure. It's their partially filled d orbitals, or their shielded f electrons, that give them all these unique properties. And this is the source of their power, the power to act as catalysts, to create powerful magnets, and to produce all those vibrant colors we see on our screens. Okay, Section 2, a smartphone's chemical secrets. Now, let's see this specialist toolkit in action. And you know what? You don't have to look far at all. It's right inside the smartphone in your pocket. A single phone is a perfect showcase. It often contains more than 10 different D and F block elements. Amazing, isn't it? So let's imagine we're opening up a phone and finding out where these specialists are hiding. We'll look at 3 key parts. First, the speaker, then the screen, and finally the battery. Okay, first up, the speaker. Think about it. That really powerful sound coming from such a tiny device. How is that even possible? Well, it's because of an incredibly strong magnet. And what makes this magnet so special? It's made with neodymium, which is an F block element. In fact, these neodymium magnets are the strongest permanent magnets that we know of. That's why the speaker can be so small and so powerful. All right, next up, let's look at that glowing screen, those vibrant colors. They are created by special materials called phosphorus. And guess what? These phosphors use F block elements, which you might also know as the lanthanoids. For example, an element called europium gives us those brilliant reds, and another one, terbium, creates the vivid greens. Their unique property is that they can absorb energy and then re-emit it as very specific bright light. And finally, the heart of the phone, the rechargeable battery. Now this is where a key D-block element, cobalt, plays a vital role. You'll find it in the cathode. And cobalt's special ability? It can easily switch between different oxidation states. It's this flexibility, this ability to change, that is exactly what allows the battery to store and release energy so efficiently again and again every time you charge.
Okay, Section 3, 3 world-changing examples. Now listen, these specialist elements do much more than just build our phones. They are literally building our entire modern world. Their unique properties are helping us solve some of humanity's biggest challenges. So let's look at 3 huge world-changing examples. First up, Application 1, saving lives with medical imaging. Let's talk about medicine. The ability for doctors to see inside the human body with incredible clarity, this has been completely transformed by these elements, and this leads to much earlier, much more accurate diagnoses of diseases. So here's how it works in practice. When a patient goes for an MRI scan, they are often given something called a contrast agent. This agent contains the F block element gadolinium. Now, gadolinium has these unique magnetic properties. It's paramagnetic, and what this means is that it interacts with the water molecules in our body. This interaction makes certain tissues, like maybe a tumor, stand out and appear much, much brighter on the scan. This helps doctors spot problems really early. It's a truly life-saving application. Okay, Application 2, cleaning our air. Second, these elements are helping us clean our air.
They are right on the front lines in the fight against vehicle pollution. In fact, every modern car you see on the road has D-block chemistry working hard inside to make our air safer to breathe.
So inside a car's exhaust system, there is a device called a catalytic converter. And this device is coated with D-block metals, like platinum, palladium, and rhodium. Now remember their special electron structure we talked about? Those partially filled d orbitals? Well, that's what makes them master catalysts. They perform a kind of chemical magic trick. They instantly convert toxic exhaust gases into harmless substances like carbon dioxide and nitrogen.
And finally, let's tackle a really interesting question about the F-block elements. You've probably heard them called rare earth elements. Now, the name itself suggests they are very, very scarce, right? But is that actually true?
So you might think they're rare because there just isn't much of them in the Earth's crust. But actually, that's not true at all. Many of them, for example cerium, are more abundant than common metals like copper or lead. The real problem is that they are industrially rare. What does that mean? It means that because all the rare earth elements have very similar chemistry, they are always found mixed together in nature. And separating them from each other is an extremely difficult and expensive process. That's what makes them so rare and valuable for industrial use.
All right, so let's quickly recap the main takeaways from today. First, I want you to remember our main analogy. D and F block elements are the specialist toolkit of chemistry, essential for those high-tech jobs. Second, just think of your smartphone as a perfect pocket-sized example, with its neodymium magnets, lanthanoid screens, and cobalt battery. And third, remember their massive world-changing impact, from saving lives with MRI scans to cleaning our air with catalytic converters.
So when you are studying for your exams, just try to remember these three things: the core idea of the specialist toolkit, the mental picture of all those special elements inside your phone, and one big real-world example, like the gadolinium in MRI scans or the platinum in catalytic converters. I promise you, if you can do that, this topic will feel much, much lighter. Keep learning, and I will see you in the next class.